Hey guys!
Welcome to Keeping Up with the Chemists.
With a K.
Where in today's mukbang, we'll be teaching you a little bit about predicting products.
To start things off, I'm Nuvia and I'm going to be teaching you guys about decomposition.
My name is Jasmine and I'm going to be teaching you guys a little bit about combustion.
My name is Kiara and I'm going to be teaching you guys a little bit about double replacement. My name is Natalia and I'll be teaching you guys about synthesis.
I'm Cynthia and I'm going to be talking about single replacement.
1, 2, 3.
I hate burgers. I don't really like burgers, but...
Okay.
Oh. Say hi. Say hi. What's
That's
wrong?
on you.
Al.
Let's see it.
No.
No.
Synthesis is when you have an element.
Make like different poses so we pick one.
So for synthesis is when you have an element plus an element to create a compound. So this is the basic equation, which is A plus B equals AB. So this is a practice problem, which is Na plus O2, which would yield NaO2. Here's another practice problem, which is NaCl plus O2, which this would yield NaClO2. And that, guys, is how you do synthesis. Thank you.
So, single replacement consists of an element plus a compound, and it is the reaction in which one element is replaced by another one. So, the basic equation for this would be A plus BC, which yields AC plus B. An example is Cl2 plus NaI. So, that would create Cl2I plus Na, since Cl2 would be A and NaI would be BC. A different equation is Al plus CuCl2. That would yield to AlCl2 plus Cu.
Thanks, it was my idea.
We're going to have a mental breakdown.
In 3, 2, 1.
She's
I'm the mother.
Kris Jenner.
I'm not just saying that. I know you did not even say I was Bruce. Hi guys.
Okay, well I'm definitely Kylie. Okay, so next we're going to be talking about double replacement. The basic format would be AB plus CD yields AD plus CB. So basically it's meaning that you switch cation ions and your what is it? Anions?
Yes.
To create two different compounds. This has to do with the activity series and the solubility rules, which we'll get into later. But a practice problem that I would use would be K2CO3 plus BaCl2 yields K2Cl2 plus BaCO3, which means that you just basically switched the B and the D, like I said, in the basic format. Another example could be AgNO3 plus KCl yields AgCl plus KNO3. It has to be Kendall. Kendall.
Yes,
Jasmine
Kendall.
I thought you meant there was a Jasmine Kardashian.
Oh!
Yeah.
She said you're Bruce.
Oh, for the best 5 minutes.
So like how I said, I'm going to be teaching you how the predicting product works for any type of equation that is determined as a combustion. So basically combustion is just any equation that has carbon, hydrogen, or oxygen. It has a mixture of those three elements all throughout. So here we have our first example. We have C6H6 plus O2. And the thing with combustion is that it will always and forever always equal carbon dioxide plus water, which is CO2 plus H2O. And that it's always going to equal that no matter how many C's you add in, no matter how many H's or how many O's, it will always and forever always yield carbon dioxide plus water. So that's the beauty of it, where it's really easy to the extent where it's always going to equal carbon dioxide plus H2O. So getting more deeper into this equation or problem, like I said, C6H6 plus O2 yields CO2 plus H2O. So like I said, it's always going to equal that. So this is an example showing that. And then a little bit more complex problem, but in all reality, it's not. We have C2H5O C2H6 plus 6O2. It's still going to have the same structure where it's going to equal or yield CO2 plus H2O, but it's just going to have different coefficients. Because here we have more C's than in the first problem, because the first problem is a more basic problem. So then this equation, because once you balance it out, it will yield 4 CO2 plus 5 H2O. So like how I said, it still has that basic format where it's always going to yield CO2 plus H2O. It's just a matter of different coefficients.
All right, guys. So now I'm going to teach you a little bit about solubility rules, which comes into play with double replacement reactions. So both reactants must be soluble in water when it comes to double replacement. And at least one of them, if at least one of them is soluble, then it will be moderately soluble, so that's still okay. So then when the products that are yielded, one has to be soluble and the other has to be insoluble, and the insoluble product is what becomes the precipitate. So the rules in the solubility table are all sodium, potassium, and ammonium are soluble. All nitrate, acetate, chlorate, and perchlorate salts are soluble. All chloride, bromide, iodide salts are soluble, except those that have lead, silver, or mercury, because they're not soluble. All fluoride salts are also soluble, except if they have magnesium, calcium, strontium, barium, or lead, because they're not soluble. All sulfate salts are soluble, except if they have calcium, silver, mercury, 1, strontium, barium, or lead, because they're not soluble. And then non-soluble ionic compounds are hydroxide and oxide compounds, except if they have sodium, potassium, and barium, because those are soluble. Sulfide salts are not soluble, except if they have sodium, potassium, ammonium, or barium. Carbonate and phosphate salts are not soluble, except if they have sodium, potassium, or ammonium.
Alright,
so now I'm going to be talking about decomposition. So decomposition is basically decompose, also fall apart, basically. One reactant yields 2 or more products, or elements or compounds. Normally energy is required. So the basic format would be AB yields A plus B. One example being 2Ag2O would yield 4Ag plus O2. You can notice when it's a decomposition reaction because you have one whole reactant yielding 2 separate products. And another example would be RaCl2 yields Ra plus Cl2. Again, you have one whole reactant yielding 2 separate individual products, compounds, or elements.
They became boyfriends. Like they got together. I don't know if that's what she meant by got together. I doubt it. But no, but
She got a fat head. That's what she
that's what I
has.
was about to say. Like literally. She had a big head. This is a very successful well, as you may notice, kind of lost half of our crew. That's okay. Because we're gonna I'm gonna talk to you a little bit about the activity series. What Cynthia was saying. So the activity series ties in with how Cynthia was saying with single replacement. Just how Nuvia said that solubility applies to double replacement. So what the activity series basically determines is if a single replacement reaction will actually occur. Because there's many cases where the equations won't, how they're set up, the reaction won't occur. So basically, just a little summary, a little something about activity series is that basically the activity series is a rank of elements based on their reactivity. And that's based on their oxidation and how strong a element is in order to take an electron. So one of the most reactive would be potassium, because they're more closer and have that more of ability to take an electron, rather than a more weaker one, which would be gold, which is has a very low reactivity, because it has less of a chance to take away that electron than potassium does. So an example being here, we have Al plus Pb, NO3 2. So here, this reaction only occurs because aluminum is more reactive than lead here. So this reaction only happens because aluminum was able to steal NO3's electrons. So that's why the order and how they're ranked, and you will see that aluminum is ranked higher than lead, which is why lead was left alone and aluminum was placed aside nitrogen.
1, 2, 3.
If you guys enjoyed the video, make sure you guys smash that like button.
Don't forget to comment and subscribe down below.
Also, don't forget to turn on your post notifications on.
And thank you for keeping up with the chemists.
With a K.